Hi, I hope you're doing well. Today, we're going to learn how to find the equation of a circle that's inscribed by 3 points. Every 3 points in 2D space always gives us a circle, unless those 3 points are in a straight line, which on our little visualization, you can see as one goes past the line of the other two, it kind of goes off to infinity and comes back round again. So that is basically that, the radius is going up to infinity, and then comes back down again on the other side of the line. Okay, step number 1 then. We need to find the equations of the lines between the points. We only need 2 of the lines, so let's pick point A and point B. So we need 2 things to find the equation of a line between 2 points. We need the gradient between those 2 points, and also the y-intercept of the line. The gradient we'll call M, and the y-intercept we normally call C, but because we've got this point C up here, we'll call it D instead. So to find the gradient, we need to do the difference in y's divided by the difference in x's. Which if we choose points A and B, it's going to be by minus ay divided by bx, take away ax. For the y-intercept, we'll look at the equation of the line, which is y equals mx plus d in this case. And if we rearrange that for d, what we get is that d is equal to y minus m times x. So if we plug in some of the values above, the x and the y will come from one of the coordinates. What we'll get is that d is equal to by minus m times bx. So now that we've got these lines, we can add them to our visualization. As our points move around in 2D space, you can see how the lines stay attached to the right points, always moving around with them. Next step then, we need to find the midpoints of these lines. We'll use point A and B, but we'd have to do exactly the same thing no matter which point we choose. So normally, midpoints are the average of the 2 points. So we need to take both the coordinates, the x coordinates and the y coordinates, add them up, and divide them by 2. Now we can add these midpoints to our visualization. You can see that they move around in the middle of the 2 white points, always sticking on the pink lines that we have so far. No matter where our white points go, our blue points are always in the right spot. For our next step, we need to find the perpendicular bisectors. Perpendicular in 2D space means right angles, and bisector means to divide something exactly in half. This is why we needed to find those midpoints earlier on. So what this means altogether then, is that we're going to have lines that go through the lines we found earlier at a right angle and exactly in the middle of the 2 points on the line. So if we think about what we've just found, we can say that the gradient was m, and for the midpoint, we'll call that point P. So the x-coordinate will be px, and the y-coordinate will be py. The gradients of the line and its perpendicular have a special relationship. Whenever we take the product of those 2 gradients, it will give us minus 1, which, if we rearrange, we can think of one as being the negative reciprocal of the other one. And this step is actually a lot like the step from earlier, where we were finding the equation of the lines between the points. Here, though, we've already got the gradient, so it's just the second half of that section. So let's find this equation then. Our gradient is going to be negative 1 over m, where m is the gradient of the line between the 2 points. And the point we need to use is that midpoint. So again, if y is equal to mx plus d, d is equal to y minus mx, which if we plug in the values we know, we can see that d is going to be equal to py minus, but this minus and this minus up here will make a plus. So py plus px divided by m. So we can add those perpendicular bisectors to our visualization from earlier. So I've put them in orange, and we can see how as again the points move around, those perpendicular bisectors always perpendicularly bisect the line between the 2 points, or any set of 2 points that we want. The next step then is to find the intersection point of these two perpendicular bisectors. If we think of these two bisectors as having equations y equals m1 x plus d1, and the same then with 2 instead of 1, what we need to do is set these two bits equal to each other so we can find the x-coordinate, take that x-coordinate, plug it back in to get the y-coordinate. So setting these two equal to each other, and we bring all the x's to one side and everything that's not an x on the other side, we'll have m1 minus m2 lots of x is equal to d2 minus d1, and dividing by this bracket, we'll get x is equal to d2 minus d1 divided by m1 minus m2. So now then we'll take this x-coordinate and we'll stick it into either of the equations that we have for the perpendiculars. Doesn't matter which one, because they should both go through that point. But before we do that, we'll give x a subscript of c. The reason being is because this is actually the centre of our circle. And we'll do the same for y. And then y is equal to m1 times xc plus d1. And again, we can add this onto our visualization. I've got it in light green on there. And we can see how as the points move around, this is always the intersection of the two orange lines, which are our perpendicular bisectors of the two purple lines. So on to the final step then. We need to find the radius of this circle. And the way we do that is to find the distance between any of the points on the circle and the centre we've just found. So to do that, we'll find the difference between the x-coordinates and square that. Do the same thing for the y-coordinates and square that as well. Add the two together and then square root. This is just Pythagoras' theorem, but in disguise. Instead of having like all of it squared, you've basically taken the c and square rooted it and square it the other side as well. And now that we've got this radius, we're able to write out the equation of our circle. We'll have x minus xc, the x-coordinate at the centre, all squared, plus y minus yc, the y-coordinate at the centre, all squared, is equal to r squared. And this thing again is Pythagoras, but in disguise. You can see a squared plus b squared equals c squared. And lastly then, we can add this all on to our visualization. Now you can see as we move the white points around, we've got the lines that join them up, we've got the perpendicular bisectors, and we've got the circle that's inscribed by these 3 points. So thank you very much for watching. I hope you enjoyed it.